So in this problem, it's different from the other problems we've been doing because we don't know the angle. Instead, we have the lengths of the sides. So instead of trying to find the lengths of one of the sides, we're trying to find the angle. In order to do that, we have to use something called an inverse. Because this thing is connected together. I don't know if you remember earlier when someone suggested that the problem we were doing, we were dividing by 4, and I said 24, I mean. And I said, no, we're not dividing by 24, we're dividing by the sine of 24. That's an entirely different thing. 24 is a number you can count to that's 24, right? Sine of 24 is 0.4067. It's a totally different number. So, whenever you have sine, cosine, or tangent, it's linked to that angle. And we can't just easily get rid of that unless we have something like an inverse to break it up. Okay? So we use this thing called the inverse sine. And when we're working with an inverse sine, we write it like this. Sine with a little -1 power. Okay? That means it's an inverse sine, and that has the power to break this up. Okay? So what we do is use the golden rule of algebra. The golden rule of algebra says, do to one side as you would to the other, right? So if I want to take the inverse sine of one side, then I do the exact same thing to the other side. Okay? Now what do you think happens when I have an inverse sine and a sine right next to each other like this? They cancel each other out, just like a square cancels out a square root. Okay? So then we have x equals the inverse sine of 12 over 24. There are two ways to do this problem. Both of them involve a calculator, but one of them involves a scientific calculator, and one of them can use a simple calculator with the green chart. Okay, let's do this using the chart method first. First thing you want to do if you're using the chart is to go ahead and divide these two numbers. So divide 12, divide 24. That should be pretty easy to actually do in your head without a calculator. What do you notice about the relationship between 12 and 24? It's not 2. They're okay, if you go 12 divided by 24, or if you reduce this fraction, 12 over 24, what does it reduce to? 1/2, which is a completely different number than 2. Okay, so 12 over 24 reduces to 1/2. What's another way of saying 1/2? 0.5. So I can change this fraction to a decimal. So then I have the inverse sine of 1/2, or 0.5 instead. Now let's go ahead and use the chart. Which column on our chart represents sine? Do you remember? It's the first column. You know how earlier today when we were doing the sine of 24, we looked up 24 and we found the sine. This time we're doing the inverse sine. That just means we're going to go backwards. So all we have to do is look at the sine value and find as close as we can get to 0.5. Oh, look, there, it's exact. 0.5. So since sine is 0.5, the angle is what? So the answer is simply x equals 30 degrees. Isn't that kind of cool? Yeah. So all we're doing on this assignment is going backwards. Now let me show you how to do the same exact thing using a calculator, a scientific calculator, okay? It is a 30, 60, 90 triangle. That was just like a coincidence, but it is. Good observation. Okay, let's do the same problem with a calculator. What do you notice right there in little yellow writing above the sine? It has a sine -1, which is called the inverse sine. Okay? If you use the iPod calculator, to get that you have to turn it sideways, and then up in the corner there's a shift button you can change to, and that will give you your inverse sine. Okay? On this one though, all I have to do is go second sine, And then in parentheses, I can either type in 0.5 or I can do 12 divided by 24. Now, if you're using the iPod, you're going to want to do 12 divided by 24 equals first, and then do that shift sign button. Okay? So, if I hit enter, what answer do you think I'm going to get? Make a guess. What's going to happen when I hit enter? What answer am I going to get?
0.5.
No, because I'm doing the inverse sign of 0.5.
Negative 0.5.
No.
0.5 to the...
We just barely found the answer using the chart. We're going to get the same answer with the calculator.
30 degrees.
Good. So we should get a 30. Did we?
Yeah, buddy.
Yes, we did. Okay. So we can do the same thing on the calculator.